Good morning, dear children. Let us start with our next chapter, that is chapter 8, Comparing Quantities. Okay, what do you mean by comparing first? What do you mean by comparing? If I talk about comparing, which is taller, which is smaller. If I talk about the height, if I talk about he is fat, he is thin, again we are comparing. He is tall, he is short, again we are comparing. What do you mean by comparison? When we find the difference between the two. If we are comparing, we are finding the difference. He is good, he is bad. Again in that context, we are comparing a person. So what is comparing? The difference of what? Of two quantities. Of two quantities. This quantity, for comparison, we need at least two quantities. I cannot compare one person with itself. I need another person to compare with. Are we clear? That is what is comparing quantity. What do you mean by quantities? Understand? If I talk about the quantities part, quantities means anything which can be measured. Things which can be measured, right? This is what quantities means. Are we clear? The things which can be measured. Clear? So we have divided this chapter into four segments. I have divided this chapter into four segments, namely ratio, proportion, unitary method first. Then we have percentage. Then we have profit loss, CP and SP. Then we have very new term for you, simple interest. I think ratio, proportion, unitary method, percentage you have done in the previous classes also. I think simple and plus is new for you. So let's have a recap. What do you mean by ratio? Ratio means, if I talk about ratio means fraction, simple, fraction, A by B. This is what ratio means. And how we represent? We represent A ratio B. This is the symbol of ratio. Clear? Next, proportion. What do you mean by proportion? When two ratios are equal, then they are said to be proportion. For example, A ratio B proportionate to C ratio B. This is the sign of proportion. So, for the proportion, we need to have two ratios equivalent. Okay. Unitary method. What do you mean by unit? Unit means one. For example, I have purchased 6 pens from the market and the cost of that 6 pens is rupees 30. And if somebody asks me, what will be the cost if I purchase 10 pens? So what I have to do, in that case, first of all, I will find the cost of 1 pen. 30 pens for 6 rupees, it means 1 pen for 5 rupees. What will be the cost of 10 pen? 10 into 5, 50. This is what unitary method. That first we find one quantity and then other quantities. This is what unitary method is. Finding the value for one and then finding the value for others. This is what unitary method is. Are we clear? Now, very important, percentage. We use percentage in daily life. You will heard. What is the percentage in class 10? What was the percentage in class 12? What was the percentage in class 7? Whatever the class you are. What do you mean by percentage? In very short and very simple language, fraction whose denominator is 100. If anyone asks you that what do you mean by percentage, a fraction whose denominator is 100. This is simplest language. Clear? It is denoted by this sign. I hope you have understood this. You have seen this percentage sign. Next, profit and loss. CP and SP. Before that, what is CP? Cost price. You went to the market, you bought something, you purchased something. The price at which you bought something is CP. Clear? Now you didn't like that part, you thought to, okay, let me sell it. What you will be going to do, the price at which you will sell, that is called SP, selling price. Bought, sold. Are we clear? Now there are two conditions on SP and CP. If your SP is greater than CP, you are in profit. For example, you purchased a pen for 5 rupees but you sold it for 7. Means you got extra 2 rupees, it means the profit of 2 rupees. That is what profit. Now same condition, you bought the pen for 5 rupees but you sold it for 3 rupees. You have a loss of 2 rupees. Loss. SP greater than CP, profit. CP greater than SP, loss. New term, simple interest. Where do we keep our money? We keep our money in bank. We have something called bank. What is the purpose of bank? Only for keeping the money? No ways. For example, you need urgent money but you are not having that sufficient amount to pay. What you will going to do? You will go to your bank, respective bank, you will ask for the money. The money which they gave you is known, basically the money which they give you is known as loans. What we call them as loans. Now, for example, you purchased 50,000 or you borrowed 50,000 rupees from the bank. Borrowed. Borrowed means which you have to return. Purchase means it's yours. So we'll use the word borrowed here. So do remember, whenever we are asking for money from the bank, we always use the word borrow. Okay, I borrowed the money from the bank, 50,000 rupees. What do you think? The bank will be asking me, okay, after 7 days, please return 50,000 only. Never. Then why a bank is giving you the money? And on what trust the bank is giving you the money? The thing is, if you are borrowing 50,000 rupees from the bank, you have to pay either the amount of 55,000, 60,000, maybe 65, maybe 70,000. That completely depends upon the rate of interest which we're going to study in this class. So that 50,000 to 55,000 to 60,000 to 70,000, what is that extra amount? That is what is interest, the extra amount. And that is why the banks are giving you the amount. Otherwise, you are borrowing the money from the bank, 50,000 rupees, and you are returning. What is the benefit of the bank? While the bank will give you the money. That is why they are giving you the money, because the interest, the extra amount you pay, that is given to the bank, and hence bank gets profit of that. Clear with this? The topic, I think brief is clear to you. We'll do all this in detail in this chapter. Just I am giving you the brief that what we have to do, what are the concepts, why we are talking about the comparing quantities. Now let's start with the topic ratio first. Means of comparing quantities. Very important, it's a method of comparing quantities. We are comparing quantities. Okay, very important. I'll show you what I'm doing right now. This glass is half filled and this glass is full filled. Half filled and full filled. What I'm doing right now, I'm comparing. If I talk about this glass is half filled and this glass is full filled, what I'm doing, I'm comparing the two things right now. This is what ratio means. For example, if I'm saying this glass contains 4 milliliter of water and this glass contains 8 milliliter of water, what I'm doing, again I'm comparing. Now, clear with this? So ratio is one of the means of comparing quantity. We have proportion also, we have unitary method also, we have percentage also, we have profit loss. So they are the methods of comparing. But first thing is ratio. It is the fraction, very important, I have already discussed. It's a fraction. Fraction means A by B form of one kind of quantity over the other same kind of quantity. Very, very important. What do you mean by the one kind of quantity over the same kind of quantity? What is this concept now? We need to see what is this concept all about, why he's talking about same kind of quantity. Just understand. For example, I'll take a very brilliant example in front of you. I need to compare. Can I compare this glass and this duster together? No ways, I cannot. Can I compare this glass and this marker together? No ways, because in this I'm talking about the liquid. What about the liquid in this? This is complete solid and this is the liquid part. Then the two states are different. That is why the same kind. Liquid must be compared with the liquid, the solid must be compared with the solid, or gas must be compared with the gas. But in terms of what? If I'm comparing the height, I'll be talking about the height only. The height of two buildings, I can compare. But if I'm talking about one, I'm talking about the height, one I'm talking about the area. There are two different things I cannot compare. Comparing the same kind means if I'm talking about height, it should be height for both. If I'm talking about the weight, it should be the weight for both. If I'm talking about the volume, it should be the volume for both. If I'm talking about the area, it should be the area for both. So quantity must be same. Clear with this? Next, it is denoted by, everyone knows, it is denoted by this two vertical dots. Clear? For example, A ratio B. This is what A ratio B means, A upon B. Clear? Now, where, if I talk about A ratio B, A is called first term. It is the first term because it is coming first, and hence the generic name is antecedent. Antecedent. For example, we have ancestors. This word came from there. Antecedent means the first term, the primary term, the first term, the utmost important term, where B is called the second term, okay, or consequent. Consequent means result. So maybe it is coming after this, that is why it is consequent. Are we clear? A the first term, B the antecedent, and B with the second term called consequent. Clear with this? Now, very important point. Next is the very important point, that when we are talking about, see, a ratio remains unchanged if both of its terms are multiplied or divided by the same non-zero number. My eyes are on this word. Non-zero. Why non-zero? Why not any zero number? We can multiply. But see, for example, if I am having any ratio, A ratio B, if I multiply with 0, is there anything? Because anything into 0, 0, 0 by 0 is not defined. In higher classes, you come to know that 0 by 0 form is indeterminate form. Indeterminate form is which we cannot determine, which cannot find, we cannot measure. That is why we cannot multiply with 0. Secondly, if I talk about divide, okay, A divided by 0 and B divided by 0. Anything divided by 0 is infinity, which is not defined. Again, upon infinity, again this is undefined form, indeterminate form. That is why the number cannot be 0. That is why we consider a non-zero number. Clear with this, everyone? Now, understand the statement again. For example, I am having 3 ratio 4. Can I write 3 by 4? This is what it means. First thing, it must be multiplied or divided by same. The ratio remains unchanged if both of its terms are multiplied and divided by same non-zero number. Same. It means if I am dividing the numerator with 3, I must divide the denominator also with 3. I cannot make it, okay, numerator by 3, denominator by 4. No. Understand why. What is the result? 9 upon 12. If I cut 3 3s, I am getting 9 and 3 4s are 12. Don't you think they are even still same even after multiplying with 3, because 3 3 is cancelling out. That is why the ratios remain same if we multiply or divide them with the same number. Understand again? 6 ratio 8. Let me divide it by 2. Let me divide it by 2. Before that, 6 ratio 8. If I cut, I'll be getting 3 by 4. Yes or no? Now 6 ratio 8. If I'll divide by 2, I'll be getting 3 by 4. See, same ratio again we are getting. So don't you think the property is completely fulfilling, that even in the case of multiplication or division, the ratios are same? That is very important. Clear? Any doubt anyone is having with this? I will see a few examples also later on, that what is the ratio. Now tell me, yourself will tell me, I have taken 5 ratio 6. Is this correct according to you what I have done? What do you think? Am I correct? No, I am not correct, because the numerator I have multiplied with 6 and denominator I have multiplied with 7, which is not a true condition for the ratio. The ratio terms must be multiplied with the same number. Either I have to make this 6. If I make it 6, I'll be getting 30 upon 36, which is quite 5 6 are 6 6 are again. I'm getting 5 upon 6, 5 ratio 6. Completely full. Are we clear? This is very important condition. Next, this is I have written A ratio B. Then I have written A ratio B is equal to A ratio B ratio N. Are we clear? Next important condition, ratio in simplest form. Very important. I think you have already done fraction in the simplest form, which cannot be reduced further. Like 1 upon 2, 3 upon 4, 5 upon 6, 7 upon 8, 7 upon 99. Are we clear? 7 upon 88, we cannot do. They are in simplest form because they cannot be reduced further. But in ratio, understand, what do you mean by the simplest form? The same condition, there is no change, the condition is still same. That if in ratio A ratio B, A and B is having HCF part. Again, the very heavy term we are having. That what do you mean by HCF? HCF for you is highest common factor. This is the prominent definition. If I ask you, you will give me. Yeah? What do you mean by factors? Means parts. Factor means parts. Now understand HCF. If I am talking about 6 and 8, if I ask you what is the HCF of 6 and 8, what you will do? You will break 6. How you can break 6? 2 into 3 into 1. These are the factors or not? If I not put multiply sign, these are the factors. Because 2 into 3 is 6. 2 I am getting. This is what the condition. Even 6 is one of the factors. Are we clear? Because 6 1 is 6. Now understand 8. If I divide 2, 1, 2, 4, 8. This is what the factors of 8 are. Because 2 4s are 8, 1s are 8. So we are getting the factors. Factors means 8 can be divided by what numbers? It can be divided by 1, it can be divided by 2, it can be divided by 4, it can be divided by 8 itself. Now, if you observe, what is the common number between this? 1. Yes. What is the another number common between this? 2. Between these two numbers, which is highest? 2. That is why, what is the HCF of 6 and 8? What is the answer? Answer is 2, not 1. This is what HCF means. HCF, what you will do? You will do the factors, you will divide the number into factors, and then you will see the highest and the common factor between it. Clear with the HCF? So, if I am talking about the simplest ratio, in the simplest ratio, the HCF must be 1. It means, I am writing the examples of simplest ratio. 1 and 2 because HCF is 1. 3 and 4 because HCF is 1. 5 and 6, HCF is 1. So 1 ratio 2, 3 ratio 4, 5 ratio 6, 7 ratio 8, 9 ratio 10, 11 ratio 17, etc. are all example of simplest ratio because their HCF is 1. HCF is 1. HCF is 1. HCF is 1. I am talking about HCF, I am not talking about the LCM. Don't misinterpret the two. HCF and LCM. Clear? So this is clear. Last definition for ratios, equivalent ratios. What do you mean by equivalent? Equal. Equivalent means equal. Either two markers are equivalent to each other or not. They are equal. This is what equality means. Why? How will be getting equivalent ratios? Same. If I multiply or divide the ratio with the same number, I will be getting equivalent ratios. For example, best example I am taking. If I reduce, I will be getting 1 by 7. If I am reducing, I will be getting 1 ratio 7, 1 ratio 7. So can I say 2 ratio 40 and 3 ratio 21 are equivalent ratios? Can you give me another example of equivalent ratios? Let us take, I'll take the example 3 by 4 and 6 by 8. Again they are equivalent fraction because this is 3 ratio 4. If I cut 2 3s are and 2 4s are, again I am getting equivalent fractions. So equivalent ratios 3 ratio 4 and 6 ratio 8. What I did, how I got it? I multiplied with 2, I multiplied with 2. I got the answer. So I hope you are able to do the equivalent fractions yourself. Just multiply it with any number, but numerator and denominator must be same in that case. Are we clear? That's all for today in this class.